So we're going to showcase a second enabler of the FI content media and content enablers, which is the 3D map tiles SE. So we start on the try level where people hopefully get interested in our specific enablers and can get into touch with those using live demos that are running on an instance in the FIWARE lab. So this demo in particular we prepared for the FI 2 in Munich. So as you can see, there are tiles loaded with a ground texture coming from OpenStreetMap and some extruded buildings as blocks on top of it, and in addition some POIs showing cafes on the Munich campus. When we get interested at this point in such a specific enabler, we can change to the tweak level and get more into it by starting with prepared playground examples to experiment with those enablers. So here we got the playground example for the 3D map tiles SE. So this showcases one tile from Hamburg. It's the places where the event of one of the FIWARE accelerators took place. So in fact we can see our HTML document on the left that contains an XML 3D scene with two models. So in fact it's the asset that is already contained in this example, so that's why the loading is pretty fast, and showcasing two layers, first the ground plane and second the buildings on top of it. We can now start editing this scene by adding comments, and thereby, for instance, hide the buildings from of this tile. We can switch from those pre-packaged assets to a running instance of the 3D map tiles SE by removing So instead of using those files that are in the dummy folder, we now perform an actual request to an instance in FIWARE Lab. And as we can see, it worked. So we get the same tile from this instance. We can also show that there is an endpoint available, and we can, as we did no valid requests, get to the API description and get more information how to retrieve those assets.
So actually, that's a good example of the try level plus tweak level, because you just showed the running endpoint in FileLab, which is sort of the try part of FSC2 Lab, and now you're editing the client-sided code of the enabler command.
Right. The tile we requested is at the resource given here, so I now change our invalid. Oh, there's something wrong. Ah, no, that's right. Our invalid request to valid one. The main entry point here returns those two model tags that we inserted into our example here. These two. They are referring to another file with the suffix -asset. So we can do this manually as well. And here we retrieve the actual XML3D resource that contains asset mesh with some building footprints in tile space and a data flow that performs the extrusion to generate the geometry. So the actual delivery is only those 2D footprints in addition to an height, so that we can perform the building extrusion completely on the client. As you can see here, there is one asset called all, so it's recursive assets that contain two other assets. One is the plane, which refers to this quad on the ground with the ground texture and a building layer for all those geometry. Okay, we can also change in our example the location. So here we showed Hamburg. On the try level we showed the Munich campus. So here we see a piece of Brussels where the FIWARE took place. So it's here, somewhere here, the egg. But we have other hate Mac.
Doesn't like you either.
Oh, something got wrong. So,
Yeah.
So this is another demo showcasing the center of Brussels. So this is the Brussels Midi train station, and there was a FIWARE event somewhere here in the hotel. So what you can see here is pretty much more geometry than we showed on the other tiles. In fact, it's one LOD above.
One level of detail. More.
Yeah, one level of detail. Okay, and finally, we can also move to our own location, which is Pixel Park. And it's this building, right?
Right.
So I picked the right. So we now, by the way, changed to use the all asset. So we include all those recursive assets automatically and need only one model tag remaining. We can now start, as those are tiles, to add the neighboring one as well, and put them aside so that we finally get 4 tiles that fit together seamlessly. And it's now feasible to implement some tile managing to automatically load tiles of the surrounding and so on. When we are at this point, so it's not obvious where we are exactly here. So when we would prepare the invitation for this event, one would put something like this onto website to point to the place where you have to go. In fact, we could change the icon, but well.
Cool.
Okay, so now we got an example using virtual 3D cities, including POIs if desired, so 3D POIs in fact. We can now somehow start over. Do we? Yeah. By just removing our session and reload our tile from the beginning. But however, we stick to Pixel Park for the following usage scenario. So here we are again. We get the assets from the 3D Map Tiles SE as one pre-packaged tile. However, from OpenStreetMap, we are provided with OpenStreetMap IDs to identify single geometry on this tile. So, in fact, we can now start to override properties of those meshes. So that's why we distinguish again between the plane and the buildings, and we take an asset mesh with this ID. So this is in fact contained in this XML file, and we override the diffuse color of this asset mesh by a new one. So this should colorize the Pixel Park's building with blue. We can also somehow pick a lighter blue. So here we override a property of an asset mesh with a static value. In fact, we can do this for every asset mesh. We can override arbitrary properties like transparency, like other colors. So if depending on the lighting model you use for your 3D scene. And in addition to that, we can also utilize data flows to automatically calculate properties for those asset meshes. So thereby we declare, instead of this part, a generic data container that reference to data flow, which in fact is an external one, and it provides finally a diffuse color. Therefore, it uses input like two colors, min and maximum value, and a gradient, so the current value in between those min and max, and then interpolates between those two colors. So when we save this, so the 450 is pretty close to the 500, so we get to a reddish color, and if we reduce this, so the current value of, let's say, sensor or whatsoever, then the interpolation is more to the greenish one. So the colors are already chosen in a way that we could, for instance, visualize the energy consumption of buildings. However, therefore, we need to automatically set this value here and update it regularly. To perform a respective request, we need jQuery. And in addition, we can write a small script such like this, which does a request once per second to a URI where our sensor is located. So we can just query this manually to see what we get back. So we have some JSON structure, and in fact we have our energy consumption and the value of the energy consumption. F5 is refresh. So, and this value changes over time because it's a fake sensor. However, in our example, we query for this and use the data we get back from this data structure, so the energy consumption value, to put it into an element called sensor, which is in fact this float value here. So if we store it now, then a request is done once per second, and as we can see, the color of the building changes accordingly. Finally, the 3D map tiles SE, as we showed it so far, uses mainly the OpenStreetMap backend, but it is also capable to talk to several other backends as well. For instance, the GIS data provider GE, and there is, therefore we can use this by start over again. And change our model to Oulu, which is a city in Finland. And we use data from the GIS data provider for the building footprints and aerial imaging from the same instance. Basically, that's it.
Great. Thanks.